I have to start with a thank you for the hobbit-sized podium. Because usually I start with, can you hear me? Can you see me? But I don't have to do that this time. I'm Paul. I am a girls lacrosse coach. Fastest sport on 2 feet. Girls are better than boys, and you get t-shirts at tournaments that say chicks with sticks. Nothing better than that. And one of the earlier talks talked about explaining, and I had a clinic last night, and I'm over with the 7th, 8th, and 9th grade girls talking about defense. You're at 10 o'clock, you're at 2 o'clock, and they're doing it. Go over to the 3rd and 4th graders, and it's like butterfly. So you have to be able to scale your explanations down a little bit. I have a wonderful job. I am the developer advocate for PyCharm and WebStorm at JetBrains. I get to work out of my house in Fredericksburg, Virginia, or as George Washington used to say, exit 130. And Quantico's down there, and so a lot of my friends say, well, what do you do? And I say, I work out of my house in Virginia for a Czech company founded by Russians. I'm in the Boston office, but my boss is an Iranian living in Spain. So they immediately call the CIA and put me on their do not call lists and all that. But for today's talk, come on. Today's talk's a little bit funny because I gave a similar talk at a Java conference. Why would you send a Python guy to a Java conference to talk about typing? I don't know. But Python and JavaScript have both been going through this concept of introducing typing at roughly the same time. And the talks that have been going on today really have been wonderful. Some really good experiences with hard-earned wisdom being delivered, speakers that have put a lot of effort into their talk and can obviously well-polished speakers. This isn't one of those. So instead, this is going to be more of a just driving WebStorm. But first, just to find out a little bit more, raise your hand if you're a front-end person. All right, not that many. What do the rest of you do? God. All right, so for those of you that do front end, raise your hand if you're pretty good at JavaScript. Any of you doing TypeScript yet? All right. Any of you doing Angular? Any of you good at Angular? Yes. Keep your mouth shut. All right. Unless I need help, and then please come right up. So we're going to talk about JavaScript, and just like Python, you walk up to like, damn, this is dynamic. I don't have to type anything in here, and it'll just figure everything out for me. And then you're like, damn, it's dynamic. They didn't even tell me about that stupid mistake I made. And so at roughly the same time, JavaScript and Python are both introducing typing, dynamic type hinting, not static typing. And TypeScript has gotten really popular in the last couple of years as a gradual superset. You can just start with normal JavaScript, and as you buy into the Kool-Aid, you can sprinkle some stuff into your JavaScript and get the benefits of TypeScript. The fact that Angular picked up TypeScript had something to do with its rising popularity, I'm sure. And the idea is that you can fail faster. Back in the good old days of there was no JavaScript in 1993, but back in the good old days of the web, you squirted something out in production, and then somebody came back and said, my screen's white, and you say, give me a screenshot of the JavaScript console. And they said, I've never heard of this word JavaScript or console, much less screenshot. And then you just try to divine what went wrong. Well, in these new days with TypeScript, a lot of your failures can happen sooner because there's a compiler. And then if you hook that compiler up to a smart tool by a certain Russianish, Czechish kind of vendor, we can let you know very quickly that you failed and give you immediate feedback. So the gist of this talk is about failing faster. From an IT modernization perspective, as you're doing these front ends, we'll talk a slide about it near the end, but Angular in particular has a migration strategy from Angular 1 to Angular 2, aka AngularJS to Angular. And you can also go backwards in time, put a little bit of TypeScript in your old code so that you will know if you screwed it up in your new code. So from an modernization perspective, TypeScript and failing faster can also help you in modernization. There are also these other places as a dynamic language developer that these kind of TypeScript contracts and typing information can help you. Maybe there's this new thing called Angular. Maybe they've been developing it for a really long time, trying to get it out the door going into this past April. And maybe things change a lot in beta. Maybe they change a lot in the release candidate phase. And so they're over there and you're over here and you've got this arm's length love-hate relationship with them, and you need something to enforce that relationship so that they can't shoot you in the foot and you can't kind of shoot them in the foot by misusing it. And the typing information that gets added into making it an official API helps you accommodate that. Similar to being on a large development team with senior developers who make the really hard stuff that have to be consumed by junior developers, and as we saw in the second keynote, who may be just coming up to speed and need things explained to them. How can I explain this complicated code to you? I can explain it through docs, which are never read or updated. Or I can put it into an enforceable API contractor with a compiler that backs it all up. And finally, this is the one that I put typing information in my personal projects, whether it's Python or JavaScript. Why? The current Paul and the future Paul hates the current Paul. The future Paul has no idea what the current Paul is doing, so I leave little memos to my future self by putting the type information in. So we're going to show failing faster, ways that TypeScript speeds up failure, and in particular, how Angular embraces TypeScript to help you fail sooner. That sounds funny saying it out loud, but it is kind of true. And we're going to use a sample project, what you get at the end of the Tour of Heroes example on the website, on the Angular website. So from a basics perspective, let's say I'm in WebStorm. And let me get this sized to be the right size. And I'll go to my app. I'll take off my glasses because I'm a man of a certain age. And I've got a very simple class, my app component. And it's got this decorator thing that we'll talk about in a second. But for now, I'm going to put in a constructor. It's not going to do that much, except it's going to say title equals 42. I failed faster, woohoo! Because my IDE told me that the TypeScript compiler told it that you're redeclaring a string into a number. And I didn't have to come up here and put the noise in. TypeScript implicitly got the type information from the initial definition. That seems like a big whoop. Why do I have to adopt this crazy thing from Microsoft called TypeScript? Well, that kind of bug can be really subtle and bite you so far down the tool chain that some civilian can't even report the error to you from the JavaScript console. So that's one example. Here's another one. Again, we're just at the language level. We're not in the Angular level. I'm calling a function. I'm calling a method. And maybe I had it right, and then Angular RC2 came out, and I had it wrong because they changed the API. So for example, let's say I make a get heroes. I won't put any typing information on it. It returns 42, and I say equals this dot get heroes. Oops, had another error. What's my error? Because the return value of this was a number, and so it got assigned to a title, which was a string. I could have made this more explicit by saying that this was a number, but it automatically, the compiler was able to figure it out. So in this case, I was calling one of my own, Actually, what I wanted to do was say get heroes, the limit, the number of heroes that I wanted to return. So in this case, I'm passing in, and for now, I'll do 42 to get that to shut up. And take out the explicit typing. So we, let's see. This says I'm not conforming to the API. The API wants an argument passed in. So I'll say, all right, this argument is supposed to be a number, so I will pass in 42. That's a number. Well, no, it's not a number. It's a string that looks like a number. Easy bug to miss. And so the compiler tells the IDE that there's an error. The IDE, in this case, WebStorm, could be Visual Studio Code, etc., that there's an error. I need to change this to a number. So I failed faster because the API, maybe in the past, the API was a string. And then it changed to number. So I was passing in the wrong arguments. The tooling helped me fail faster. Getting the wrong results, kind of the similar kind of thing. If the result is a string or the result is a number and I'm assigning it to a string, then the result of the API, I'm expecting it to give me back something. It gave me back the wrong thing. All right, I'll just put you back in your correct shape. So that's TypeScript itself. I'm sorry, one other thing. As I make mistakes in my code base as a whole, I may wind up with get heroes that returns a list of numbers. Somewhere else in my code base, something is consuming this that makes the TypeScript compiler fail. And so if I'll just do it in this file to show it. Your tool can show you all the compiler errors anywhere in the project, so if I don't even have that thing open, I'm like, oh yeah, way over there, the other side of the contract is broken. I'll double click and get to it. So TypeScript, the compiler in the language service, is able to handle not just the thing you're working on right now, but your project as a whole. In Angular projects, that becomes pretty important because Angular wants to have 4 trillion small files, each doing one single thing. All right, so back to reverting this. All right, TypeScript compiler is happy. Now let's get a little bit more into Angular. I've got about 7 minutes left. Is that right? Let's go through some of the ways that Angular embraces this fail faster through TypeScript. Previous presenter talked about the Angular project adopting TypeScript in its rewrite from AngularJS to Angular. It did that for a long list of reasons. They were all pretty good reasons, and it's turned Angular into a, as he said, platform for programming in the very large, which also applies to the size of the bundle files that are generated. All right, so I'm going to take a look at 2 ways that we fail faster thanks to TypeScript in Angular. I was just working on a component, and I know I'm working on a component not because there's some magic name component in the name of the class. It's because there's this decorator thing. I'm decorating my class with something from the framework, the Angular framework, that registers this class as a component. Well, that registration is my love-hate relationship with the framework. TypeScript is helping me on that by enforcing some rules expressed in the values that are set in to do the wiring. So for example, if I say DC full stack, then I get an error because that's not a legitimate argument to pass into the component. Similarly, if I changed this to 42, that would fail. Well, how can I find out all the possible values that I can pass into this? Well, my IDE can help doing its normal IDE things. I can go jump over to that code. I can say, oh, it's an interface, one of those TypeScript thingies. And this interface has that. Well, what's that? Oh, I can jump to that and keep jumping and jumping. Or I can let my tool tell me the possible choices and what are the types for those values. The router that we configure for Angular to handle URLs mapping to components, same kind of thing, very helpful there because it's hard to memorize all those possible configuration values. TypeScript can extend into your templates, out of the TypeScript, JavaScripty looking files into the templates. For example, I'm going to go look at heroes, at a template. And in this template, I don't know what the hell that thing's saying. It's supposed to be HTML, but it's certainly got Angular-fied. One of the things that it's doing is iterating over a list of heroes and making an LI for every hero. And each hero can have like a hero.id, etc. And because hero adheres to an interface, I know what's allowed there. And if I put shoe size, TypeScript will tell me that I've got an error. In fact, the whole project will report that it's got an error. The same is true for passing in arguments. The add method on my component takes an argument of a string. If I pass in something like I say, I'm not passing in anything, I'll get I should be getting a compiler error. Let's see if I do that. Nope. I downgraded my WebStorm version just before getting here, so I must have had a different fix. And for example, if I decide to add a different button that has shoe size, the compiler knows, hey, you don't have a method on your component called shoe size. This tool in particular will help by giving me an intention that will automatically write the method on the correct component for me. All right, let me revert these guys. Go on to the next slide. This is a really important one. We talked a lot today about microservices and cloudy kind of things and putting stuff in lambdas, etc. HTTP calls that give back data. Well, you don't know. You're not in control of that other thing. It's not in your code base, your co-developer's code base. It's out there. How can I get some of the failing faster on HTTP response data? So for example, I have a heroes service. That returns has a method which returns an HTTP GET, and we stamp on it that we have a list of heroes. Well, on the heroes component, when it comes back, I know that that thing is a hero. And if I try to get information off of it that doesn't conform to the hero interface, my IDE will complain at me. Angular 1 had problems with quote-unquote dependency injection. So if I have a component that asks for some information from the framework, in Angular 1 we had to do this magical stuff. We now have TypeScript. TypeScript has types. We put it to use to say the type of the thing that we want. And same thing can be true in test writing. You can use types and failing faster to know the thing you're testing if its API changed. So from the perspective of modernizing, AngularJS to Angular helped with a migration strategy. You can run both of them in the same application simultaneously. But if you change to TypeScript, then you have an API construct that lets you know that you have broken the contract during your modernizing. And type hinting doesn't apply just to upgrading code bases in JavaScript. Dropbox employs the creator of Python. They are using type hinting to help them switch from Python 2 to Python 3. Angular is now moving a lot faster. They came out with version 2, then they came out with version 4. And the things have been changing rapidly since then. So you can use, from a modernizing along Angular perspective, typing to help you on that. So in conclusion, use typing to say what you mean and let the tools help you know if you meant it. To keep good fences make good neighbors with yourself, your future self, and your team, and to help you fail faster. Thank you.